Welcome to another episode of In Depth with Academia. I'm Richard Price, CEO of academia.edu, and today we're diving into some absolutely fascinating, this time with a deep at the work of Rajiv Singh. Today's episode explores his sweeping research, Life as Information, the Logic and Future Biological Intelligence. Is quite a, isn't, so in. As always, my here is to the paper neuter. Think of me as your academic guide. I'm offering an endorsement, but rather a chance to engage thoughtfully these intriguing ideas. Let's start at the core, the what and the why. Singh's central question is, can we understand life? Yes, the life's all around us and in us, as fundamentally an informational and relational phenomenon, is significant. Well, if we can find common ground between biology, physics, chemistry, computation, and philosophy, then maybe we start to see life not some magical exception, but as a natural, structured process in the universe. It's about connecting the dots between how matter, energy, information conspire, produce self-organizing, evolving thinking systems. Now let's talk about the journey Singh takes us on, because wow, it's a big one. The paper opens reminding us of the classic puzzle. How does life manage to be so organized when second law of thermodynamics supposedly dooms the universe to disorder? Singh argues, and this is becoming a popular, that living systems and their noses at physics. Instead, life is what happens, matter is organized by energy flows so cleverly that it stores processes and propagates information, all while jettisoning entropy into the environment. You stay tidy by making your room's mess appear in hallway, so to speak. But how does this work tangibly? Gives us a primer on thermodynamics. And living things maintain their ordered state by constantly consuming energy. Think sunlight for plants, food for animals, ATP, your cells. And by exporting disorder. This the foundation for life. Then the paper dives into self-organization. This is where things get wild. Molecules under the right conditions just want to form complex networks and structures. Lipids form membranes, proteins fold themselves with jaw-dropping precision, and even chemical cycles can appear spontaneously. The key technical insight: order arises naturally in open energy-consuming systems, but we don't at materials and molecules weaves in information theory. Life, he says, not chemistry, but code, literally with and genetic regulatory networks acting as logic circuits. That tickles your curiosity about computation, it should. The parallels between genetic encoding and computer language is striking. DNA stores digital info and proteins in a weird way, are like molecular robots, executing instructions. A digression here. Have you ever considered that a tiny bacter might compute at certain tasks? I mean, try running a full metabolic cycle on a laptop. Anyway, The argument then pulls in logic and philosophy, linking the evolution brains and artificial intelligence with the same information processing ideas. Singh suggests that intelligence, biological or artificial, be just the emergence of increasingly complex information networks adapting over time. That's a pretty bold claim. He ties in quantum information, arguing that in the life and intelligence, be they based, silicon-based, or even quantum-based, might just be special patterns of information organized under thermodynamic constraints. So, why should care about all this? If Singh is right, it changes how we see our own existence. Life is only about flesh and blood. It's flows of information instantiated in matter and driven by energy. That opens up wild future scenarios. Artificial life, quantum computing, organisms, synthetic self-replic. Who? In not saying those things will happen, just that the framework lets us even imagine them. For those of you in AI, biotech, or philosophy, Singh's synthesis a way to cross disciplinary borders. It gives a common language, information computation, that physics, biology, and engineering can understand. And for anyone just wondering why and how stuff works, well, it's kind of inspiring or unsettling. Imagine you might be a thermodynamically powered, information-rich ripple in the cosmic sea. Of course, the paper doesn't claim to all the answers. Research is always provisional, but whether by the vision or not, Singh's work sparks questions worth asking, like, what is life, really, and how might intelligence continue to, and elsewhere in universe? So that our whirlwind tour, thanks tuning into In Depth with Academia. Remember, academic is springboard for curiosity, not the last word. Keep exploring, keep questioning. Who knows what insights the next will bring? Until next time, I'm Richard Price. Stay.